Okay, good morning or good afternoon, everyone. Welcome again to APNIC eLearning web class. Today is Wednesday, the 15th of April in 2015. It's 1 o'clock in the afternoon from Brisbane in Australia, where I'm broadcasting this class. Now, this is the second session that we are holding for today, and it will run for 1 hour. The topic that we are going to cover is IPv4 to IPv6 transition. Now, before we go on to the details of what we're going to cover, I'd like to just very briefly introduce myself. My name is Cheryl Hermoso. I work for APNIC. APNIC, as you know, is the Asia Pacific Network Information Center, and we are the regional internet registry for our region. Now, I am part of the training team who conducts workshops, face-to-face trainings, and e-learnings like this on topics that relates to internet technologies. So we do cover IPv6, DNS and DNSSEC, internet resource management, network security, routing, and BGP. Now, for this session, this is provided for free to members of the internet community. This will run for 1 hour, and at the end of the session, I will be asking you to fill in a very short survey to help us gauge whether we've achieved something here or whether there are comments coming from you that can help us improve this session for everyone else's experience. Now, um, that's all about it as an introduction. Now, I'd like to go over through the overview. Um, what are we going to discuss in this session? Now, coming into the class, I'll be expecting some idea from you on IPv6. This is actually the third of a series of IPv6 related topics. We have done IPv6 overview. We also have IPv6 addressing and subnetting, and this one is about transition. So a bit of an idea on IPv6 would be good. Otherwise, if you have any questions on that, as I'm explaining, just please let me know. Now, for this particular session, we will be looking at the concept basically of transition. What are the differences between IPv4 and IPv6? How can we make them coexist, and why would we want to do that? We will look at three different major, I think, categories of the transition, let's say, or setup. Okay, dual stack, we'll use tunneling and translation. Now, unfortunately, although we will look at some examples of transition strategies and also technologies that are being used out there, I'll just give you very easy examples. The idea behind this session is to understand in a broad way how to go about your transition, how to see the different challenges, what do you need to think of or understand before you actually go on and implement your IPv6 networks alongside with IPv4. So we will look at those things, those challenges as we go on. All right, so that's the plan for the session. Now let's start with an overview of transition. And before we go on to that, just very briefly, I'd like to start by giving you some background of IPv4 relating to IPv6. Now, I'm sure most of us here are familiar with IPv4, and as you know, IPv4 internet is one that is very stable. So we are moving from IPv4 to IPv6 protocol. Now, you may be asking, why are we doing this despite the very successful IPv4 networks, right? Well, this is supposed to be discussed in another web class, of course, an introduction to IPv6. So I assume that you have attended that class before. But it's good to understand that IPv6, although it's kind of a new topic for most of us here, it's been available since the early 1990s. And the reason for that mainly is because we are anticipating a point in time in the internet history where we will be running out of IPv4. We call that the IPv4 exhaustion. And we are close to that. Nowadays, if you come to a clinic or if you come to any of the regional internet registries to request for your IPv4 addresses, you only get a minimum amount, which may not be enough for big networks or networks that are just starting out and deploying, say, their servers or their infrastructure. So what we're going to discuss today are the different technologies that can help us to migrate from IPv4 to IPv6. As I've said, when you get your IPv4 address space, it's never enough. And the reason you can get that is so that it can help you still have presence on the internet. It keeps the internet growing. At the same time, you'll have the leverage of like migrating into IPv6 networks, right? So what exactly do we mean by transition? Transition, as you know, is like an approach to transfer, to upgrade something. In terms of technology, it's a process where you have a legacy system. In this case, we're talking about IPv4. And from that legacy system, we are going to a newer system, a newer technology, so to speak. What we've seen in IPv4, and we've been using that for quite a while, we've learned a little bit about that, is that there are standards when you're transferring data. Data is transferred from source to destination using some rules. These rules are what we call as protocols, and every host that's connected to the network must adhere to these rules, right? To these protocols so they can communicate with other hosts. Now, when we're introducing, as we are introducing a new protocol, we want it to be done as seamlessly as possible. Okay? We need to make sure that during the transition process, the old system using the old protocol are still able to communicate during the entire, basically the entire transition process. Okay? At the same time, when you're introducing that new system, that new protocol, that old protocols are able to communicate with newer protocol. Okay, especially if it's in the production environment. So when you're doing transition, we want to make sure that we minimize downtime. It is important aspects of that we have to think of. Okay, when we look at the entire transition process. Now, basically, let me just use my mouse over here, my pointer. Doesn't seem to be working. Hang on for a second. So when you talk about IPv6, how do we actually get connectivity into an IPv6 network, right? So if you have an IPv6 host running IPv6, you've configured that with an IPv6 address. How do you connect that to the IPv6 internet? And it's important to understand this because of one thing that a lot of people probably are not aware of. IPv4 and IPv6 are not exactly compatible with each other. Okay, it's very important to understand that. So in transitioning from V4 to V6, IPv6 is not forwards nor backwards compatible. If I can make an analogy here, if there's like one person, an individual who speaks only English, and then another guy who speaks only another language, another local language, maybe French or any or Chinese or any other language for that matter, they won't be able to understand each other. That's the same situation with IPv4, right? And IPv6. If a machine is running IPv4, when you send IPv4 packets and it's received by a router, okay, that speaks IPv4, then he's able to transmit that and get to its destination. But if you have an IPv6 speaking machine or host and it sends an IPv6 packet, now the router won't be able to understand these IPv6 packets. And when a router doesn't understand, what he does is discard that packet, right? It's not going to go anywhere else. So there has to be a way for that to still happen, right? So your upstream going to the IPv6 internet should also understand IPv6. And two ways that we can do that is one, via native connectivity. So your upstream providers must support IPv6. Another is to use tunneling. So there are different tunneling techniques that are available. Basically, what you're doing there is your IPv6 packet will be encapsulated so that it can now go through and can be routed via IPv4 protocol. Now, there are some, and it's actually growing nowadays, there are an increasingly more and more IPv6 deployments out there, especially for core infrastructure. But going to end users, mostly if you're a subscriber to, say, say you have your ISPs, mostly they still do not provide that. Okay, there are cases that do, but in a large percentage of internet users, it's not available yet. So IPv6 deployments are still rare. So practically speaking, if you are going to deploy IPv6 now, and it's an isolated endpoint, okay, you might need to run it through some form of tunneling, or you might have to deploy both v4 and v6 so that it's still accessible via one means or the other. So that's how it is. That's the current situation that we are in. So as I've said, IPv4 and IPv6 are different. So we have to be very clear with that. This is a challenge. That's why you need a plan. We need a plan to before we actually implement anything. So when you transfer to IPv6, there should be a gradual migration process, a gradual migration plot, so that all of the machines will not lose their IPv4 network connectivity while you are doing your migration. Think of it as two different protocols. You have an IPv4 internet, you have an IPv6 internet. If we consider, I think I might have a diagram here. Um, by the way, just have a look at these IETF working groups. A lot of IPv6 specifications related to deployments, transition and translation mechanisms and scenarios are still being discussed actively in IETF. These are some, and you can subscribe and join the discussion about it. Now, going back to our transition concept, as I've said, the internet is kind of like this. It's just an interconnection of different networks, right? Routers connected, peering with another router, so one network connected to another router, and all that. It's all running IPv4 at the moment. But if you have IPv6, as I've said, there are many different deployments of IPv6. We call it IPv6 islands. So they're kind of isolated. So you have one over here, maybe you have one over there, but essentially, how can they reach each other via V6? It's still not kind of possible if your upstreams do not have that support. So what you need is some form of tunneling so that it will be running via IPv4. So you see here, you've added an IPv4 header, and then when this router understands both v4 and v6. When that packet gets out via this link or this other link here, it is IPv4 packet. Why? Because it's been encapsulated with v4 headers. So going from here, going along the path, it is interpreted as IPv4. And when it reaches its destination where you have another router, this router also must understand both v4 and v6. From that point on forward, the IPv4 headers will be stripped and it will be forwarded to destination hosts via IPv6. So that's typically how it works. And if you just look at the concept of transition, it looks very easy, but it actually depends on a lot of different, say, different networks working together, your network compatibilities as well, and you have to look at all of those different factors. In the future, however, as soon as everyone, okay, it might still even take a while, but if you look at the graph of the IPv6 routing table, I might have that somewhere in these slides, the deployments are increasing. So more and more networks are making their data, their contents available via IPv6. And at some point in the future, we will have something that is all IPv6. Going back to my analogy earlier on, if you have two different speakers, right, V4 and V6, they don't understand each other now. So what you do is one of them must learn both. Okay? Later on, as you go on, as you continue using one language or one protocol over the other, you will get to a point that you will prefer the newer one, okay? And then maybe start discarding the old once. It happens with all types of technology. And at that point, perhaps we will have an IPv6 only internet. Okay? And then all of the machines, all of the routers, all of your network equipment will be using IPv6 only. Okay? That's just the idea behind it. That's the concept. But what about the implementation? So let's talk about that because that's more realistic. In the previous ones, as I've said, um, we want to get to a point where everyone uses IPv6 because that will make things a lot easier for everybody. But right now, we're not at that point yet. And for your content to be accessible to everyone, you should be available via V4 and available via V6. So, implementation is what we should focus on when we talk about IPv4 to IPv6 transition. Um, we want to get our feet on the road and then maybe start deploying in a test environment. Start with the core and then slowly implement that and make that available to your customers. Okay, there is no fixed date to convert to IPv6. It's not like the Y2K bug in 2000 where at that point everybody should have support for this so that it won't affect your networks, right? But in this case, if even if you are just running IPv4 right now, it will still work. You are still going to be accessible. There are advantages to implementing IPv6 now. If you can like have a business case, a business model to that, but basically, it depends from one organization to another. So that's why there is still no fixed date. There is no mandate whatsoever that you have to offer IPv6 at the end of the year. There's nothing like that. Okay. So the key thing here is implementation based on your business objectives. As you know, we know that with IPv4, you have limited supply, and at some point in time, you will still have to implement that if you want your network to grow, if you want your business to grow. So the best way is to start doing it now. Okay, and of course, it will incur some costs that you have to also look into. So there are things that you have to decide upon before actually implementing it. Okay, the key thing here, as I've said earlier, is to maintain compatibility with IPv4. Okay, there are still millions of users in IPv4 network, and you don't want to ignore them just to be able to implement IPv6. There's no need to convert everything all at once. Some parts of your network might not need IPv6 at all, especially if you have legacy equipment that will not have or will not ever have support for IPv6, then you can leave it via IPv4, right? There's no one forcing you to be 100% IPv6. So you upgrade one by one. The transition process has to be gradual. Now, let's look at some of the, I would usually call them as categories of transition. So there are lots of technologies that are available out there. They all have their advantages and disadvantages. They're depending on your network, one may be best for you over the other. And at some point in your transition process, you may have to switch between these different transition technologies. So here, let's just try to understand them as a whole. So let's look at the different categories. Now, there's a wide range of techniques that has been identified and implemented, and they fall under these three categories: dual stack, tunneling, and translation. Now, during our discussion of the the transition process, we have basically looked into this. When you talk about dual stack techniques, basically what we mean there is you have both IPv4 and IPv6 coexisting. So your devices, your network equipment, both have IPv4 and IPv6 and can route to both of these networks. Another is called tunneling techniques, where you have, say, upstreams that don't exactly support IPv6 yet, so you must encapsulate your data so it passes through the IPv4 network. Another one, okay, is translation. So you have IPv6 only devices that goes through translation techniques. Maybe you have devices that can do this translation process for you. And once it gets out, you have IPv4 only packets and it's routed as it is an IPv4 packet. Now, um, you don't just select one over the other. Okay, as I've said, at any point during your transition process, expect that you'll be using one or prefer one and then gradually move to another type of transition mechanism. Or you might even end up using both of them or two of them or three of them in different parts of your infrastructure. That's how it is. Now let's look closely at dual stack. Okay, as I've said, IPv6 is not exactly a change of addressing scheme, but addressing is important when we talk about dual stack. We will be assigning IPv6 addresses onto our network infrastructure, right? Now with dual stack, this is when you install basically IPv4 and IPv6. So some idea of IPv6 addressing, okay, and address planning would come into play with this. You have a network topology for your, say, IPv4 network. How will you go about addressing these endpoints or hosts with IPv6 addresses? So planning is required with that before you actually implement it, right? So this affects your layer 3 basically most of the time, not a lot of changes in the upper layers. But you will also have to look at your applications. The applications, do they support IPv6 or can it be transported via IPv4 only? Okay. Um, what else? You must make sure that the IPv4 stack is still enabled. So if you have IPv6, if you have something like this, right? If you have both IPv4 and IPv6, some applications would prefer IPv6 over IPv4. Some applications will do some maybe checks before you select v4 or v6, or some don't support IPv6 at all, so they only go through IPv4. So it depends on the different applications. Now, if you have heard about happy eyeballs, there are some challenges that we get from implementing IPv6, and one of that is it introduces some delay, especially because most applications by default would prefer IPv6 over IPv4. So what if you don't have IPv6 yet and your devices are enabled with IPv6 by default? So it goes through via the IPv6 transport, checks if it can go out there. If not, it will default back into IPv4. So it results into some latency issues. Okay. So Happy Eyeballs is a protocol. It's actually a standard, I think. It has an RFC and it is implemented in some operating systems now and some browsers too. With Happy Eyeballs, essentially what happens is your your application, okay, will select IPv4 or IPv6 transport by doing some initial check first. So whichever is a healthier link will be chosen over the other one. So that's in a very short explanation. That is what we call as happy eyeball. So you can look it up and find out what applications have support for that particularly. All right. What other challenges do we have with with dual stack IPv4 and IPv6 implementation? First of all, you must do an audit, right? Before you implement anything, you must do an audit. You must check whether all your applications have support for this. Because one of the biggest issues perhaps would be compatibility of software, not just in the application layer, but like especially in say the firmware that's installed in your devices or the protocols that are running, routing protocols even in your routers. Let's have a look at OSPF. I'm pretty sure most of you have implemented OSPF. OSPF essentially is for your internal networks, right? It's a dynamic routing protocol. So with IPv6, so OSPF v3 is required so that for support for IPv6. If you use OSPF version 2, there is no support for IPv6 routing. Most ISPs use OSPF in their internal network. So when you install or when you implement IPv6, you must also enable or um, router operating system must also support OSPF v3. OSPF v3 has the capability of supporting IPv6 routing. So you must upgrade your systems perhaps so it will support both OSPF and OSPF v3, and they must both be running as in your routers. Okay, so although for some this may seem pretty straightforward, it will still also create some delay in the transition due to scaling issues. What if you have to do that on 100 routers as opposed to doing that to just 10? Now, most service provider networks are also content or application providers. They provide different types of services. They provide either web, FTP, mail, DNS services. This also poses some challenge since not all applications have built-in support for IPv6. Trust me, it is actually already improved from the last 10 years. So just do an audit of all your applications that you're running, all the services that you're providing, if they actually have support for IPv6, like your mail servers. Are you using something that's open source that provides v6 support, or using something that's proprietary? If it's something that's provided to you by a vendor, we might have to check with them if they don't support IPv6 yet, do they have plan to support that in the near future? If not, it might be time to find another provider, right? Another application from another vendor. So just look at these things as well. So for web servers, it must have IPv6 support. If you're running Apache, it should have that. I think it has that for a very long time now. For DNS servers, if you're running Bind, it has support since Bind 9. However, you still must understand that you need quad A records for all the hosts or servers that you deploy IPv6 with. So the key here essentially is to examine and check all the services that you need. Then one by one, check their compatibility features with both IPv4 and IPv6. Now, as we've discussed, a dual stack network needs a DNS resolver that's capable of resolving both types of DNS records. So I'll just go to the next slide here. This is implementing dual stack with DNS. So this has got something to do with what I was discussing on prioritization earlier on. It prefers IPv6 over IPv4 by default. So with DNS, that's actually the case in general. If you say have a DNS server here, you have a host here, and then it looks for say a web server, www.a.com, and then it checks with the DNS server. If you have IPv6 enabled, it looks for the IPv6 address of that server and then tries to go via v6. If it's not available, then it goes back to the DNS server to fetch for the A record or for the IPv4 address, and then tries that with the IPv4 transport. So in dual stack case, that is essentially the case. Is IPv4, if IPv4 and IPv6 are both enabled, usually your DNS will request for the quad A record first, meaning priority of IPv6 over IPv4. Okay, so if you're making IPv6 available on your web servers, just make sure that you are aware of those things as well. So this is the entire query that is happening. So you're asking basically for a quad A record first, and then it will respond with a quad A record with IPv6 address, or it will tell you that it's non-existent. So basically, there's an additional one or two requests going on there if it's not available via v4. Because yeah, we query again for the IPv4 address, and then it gives you the response. So just some extra delay that is introduced there when you're choosing when you're enabling IPv6, and not all of your services have IPv6 support by default. All right, so just be aware of those things. Now, how do you implement IPv6 and IPv4 at the same time? How do you implement dual stack? This is a very easy example. As I've said, with dual stack, as long as you've implemented both v4 and v6, you have v4 and v6 transport, then that's considered as dual stack. In a router, if you have this router, the configuration is something like this. So interface, and then in this case, that's Ethernet 0. That's this outgoing interface here that goes to both your v6 and v4 networks. You essentially just enable configure IPv4 address and IPv6 address. Notice here that when you do configure IPv6 address, it's IPv6 address and the address that you've chosen plus the prefix, not the subnet mask. Okay, that's how you do it in a typical router. The next type is tunneling. By the way, are there any questions from the class about what we're discussing? If you do, just please write them down on the chat at any point in time, and when I see it, I'll try to answer it as much as I can. Now, the next one, the next category that we mentioned a while ago is tunneling. So, how does tunneling work? We somehow touched on this in the introduction on transition process. So we have, as I've said, we have these many IPv6 networks or islands. How do we make them communicate with each other when at the core of the internet, IPv6 is not supported yet? We said that transition is gradual, so for the time being, if you're running v6 and if you want to experience using your IPv6 network, then it will have to go through an IPv4 network at some stage or at some point in a process, right? So one way to achieve that is to use tunneling. Okay, it is used on top of an existing IPv4 infrastructure and uses IPv4 to route IPv6 packets between IPv6 networks. Now, when you talk about tunneling, there are different types. It can be manually configured, manual tunnels. You can have automated tunnels. You can have semi-automatic or semi-automated tunnels. And there are many technologies that fall under these. With manual tunnels, you also have just RC2893, that's the description of manual tunnel. You have GRE, semi-automated tunnels. A good example is tunnel brokers. And for automatic, we have 624 and 6RD. Kizer is asking, if you use tunneling for the IPv6, do we need to map each IPv6 IP address to a separate IPv4 address, or one IPv4 can work for multiple? It actually depends. Usually, you do it on either relay, or a border router. So in the border router, that's when you have a dual stack router, right? So at that point, you can set up your tunnels from that router to another router, or from one router to, say, a tunnel or a gateway, but not for all hosts within your IPv6 network. So within your network, you're using IPv6 only. If it's local traffic, then you're exchanging traffic via IPv6. But once it goes out of the internet, okay, and then your upstream is only using IPv4, then that's when you do tunneling, okay? Now, there are some downsides to using tunneling. Some older examples of these technologies are quite, how do you say it? They have problems with latency, so it's not that fast. So if you are going to use this, usually only for, let's say, point to point, or from your network to some specific networks that you wanted to test with. But for your, say, internet traffic, you would usually go with either tunnel brokers or commodity traffic will just go via V4 if your upstreams don't support IPv6 yet. So one thing that you can also do is to urge your upstream providers to make IPv6 available. Let them know that there is a demand for IPv6 because they need some way, some business plan to implement, to purchase a equipment or upgrade their existing equipment to support IPv6. And that demand will be coming from customers. And if you're a customer and your upstreams don't have that yet, then let them know that you would want to, or it will be nice if they can support IPv6 for you, right? Or for all other customers as well. But yeah, going back to your question, basically for tunnels, it's usually just your border router or any router that's facing outwards that you want to connect to another network. But within your network, you can use IPv6 only. That's all good. As long as, of course, all of the hosts have support for IPv6 and are enabled with IPv6. Okay, does that answer your question, Kizer? Any other questions from the class? Okay, let me just continue with the discussion on tunnels. So I have here, I think, some examples of, I'll just skip that one. This is the general concept. We've already discussed this. You should be aware of this by now. This is what I was trying to explain earlier to Kizer. So his question was, do you need IPv6 as or IPv6 to IPv4 mapping for each of the hosts? Actually, you don't, because this is the setup that you will be following. You still need a dual stack router. So understanding how to implement dual stack still plays a very important role even if you're doing tunneling. So again, you will use one or two or even more transition mechanisms as you go on. So in tunneling, you're actually using a dual stack router. This router and the router on the other end has both IPv4 and IPv6. In here, you're using IPv6 only. Your network is IPv6 only. Once it gets out of this dual stack router, then your traffic is going to go via IPv4. It is accepted or interpreted as an IPv4 traffic. So you're doing tunneling here via IPv4. And so when it gets to its destination, on the other side, another dual stack router that understands IPv6 will then strip off the IPv4 headers and then forward that as an IPv6 packet into the destination, which is an IPv6 address or an IPv6 host. Okay, so that's how it works. So it's a two-steps process. You do encapsulation of IPv6 packets to IPv4 packets. It goes through via V4, and at the other end, it will be decapsulated, so you only have an IPv6 packet. Okay, and that is done using encapsulation like this, and decapsulation here is when you strip off that IPv4 header. Okay, how do you configure a manual tunnel? So let's just say, for example, that you have two networks, you're managing two networks, and you want to test it out. So you have two routers. These routers are using dual stack. You have an IPv6 address and IPv4 address for both, and you want to implement a manual tunnel. So how do you go about that? The configuration is quite easy. It's something like this. So you specify or you configure a tunnel, so interface tunnel 0. You provide the IPv6 address, then you provide a tunnel source and tunnel destination address. The source and destination addresses are both IPv4, and it doesn't have to be on the same subnet as long as both of them are reachable. So if you can reach router 2 from router 1 and vice versa, then that's good. However, for IPv6, notice that the IPv6 address we used for router 1 and the IPv6 address we used for router 2 are coming from the same subnet. So 2001 DB8C18:1:3, and the other one is ::2. So they are from the same subnet. So I think the challenge here is if this is managed by two different administrators or sysads or network admins, and then they have separate blocks. So here you have to agree on a block that will be used by both of these networks. Okay, so in this case, it has to be this slash 64. Okay, and then you configure that. You give the address to your tunnel, you provide the tunnel source and destination IPv4 address, and then specify that your tunnel mode is IPv6 IP. That is how you configure a manually configured tunnel. On the other side, on router 2, it's basically the same. You specify the IPv6 address, which is colon colon 2. You give the source, which is 30.1, the IPv4 address of router 2. And then the destination is the IPv4 address of router 1. Again, tunnel mode here is IPv6 IP. Okay, so that's manually configured tunnel. Now, another example of tunnels is 6 to 4. 6 to 4 for a while has become a very popular technique to implement IPv6. And to do this, basically, you don't need to have a separate IPv6 block because there is a block that is provided or reserved just for use with this particular purpose. Okay, there is a block and that's 2002/16, and from this block you can assign, okay, that to your 6 to 4 to your machines that are using 6 to 4. So notice this example. We have here again an IPv6 network. It's connected to a dual stack router. It's router 1. And then you want to create a tunnel from router 1 to router 2. And then from there again, IPv6 network. So you have an IPv4 address already assigned to your router 1 and router 2. That's 192.168.99.1 and then 192.168.30.1 for your router 2. Now notice something here. We have 2002/16 assigned for the entire 6 to 4 block. Now you will use your IPv4 address, in this case this 192.168.99.1, to fill in your network prefix. And see here, that's 2002/C0886301/48. So 1/48 assigned for this subnet, and then you have here another /48 assigned for subnet in network 2. But the from /16, you fill that in to complete the /48 network prefix. You fill that in with the hexadecimal digits or representation of your IPv4 address. In this case, 192 is equivalent to C088, should be 168 in decimal. 99 is 63 in hex. 1 is 01, of course, in hex. So that's exactly your IPv4 address. So notice that. So basically, with 6 to 4, you don't have to have a separate IPv6 block for assignment to this because you are using as a reserved block specifically for 6 to 4. Now, how do you configure your routers for this? So in this case, you assign your IP addresses on your interface. So in this case, we're doing that with a loopback interface, loopback 0. So you have there your IP address, you have there your IPv6 address, okay? And then you create your tunnel, interface tunnel 0. Notice it's a bit different because before we assigned the IP address on the tunnel itself, right? Here, you don't assign the IP address there, you just assign it to the loopback interface. And then you specify that your tunnel source is your loopback interface. Tunnel mode in this case is still IPv6 IP, more specifically 6 to 4. Okay, and then at the end of your configuration, you must say you must have this pull-up route, meaning IPv6 route 2002/16 uses tunnel 0. So you're essentially telling your network when it receives packets or traffic that is directed to 2002/16, okay, it should use the tunnel interface, okay, and it goes via your tunnel, not just via your normal V4 traffic here. That's how it is. All right, so I hope you understand that. That's an example of 6 to 4 implementation. Now, aside from 6 to 4 point-to-point connectivity or tunnels, you can also set up your networks to connect to a 6 to 4 relay. With that, it makes it easier for you to then have access to the rest of the IPv6 internet. So you don't have to specify or configure separate point-to-point connectivity to other IPv6 networks or IPv6 islands. You can just configure your machines to point to your 6 to 4 relay. Notice we're doing exactly the same thing here for the configuration of our router 1, but we are also telling that for all IPv6 traffic here, there's a pull-up route that says it should go to this IPv6 address. And that IPv6 address is the address of our 6 to 4 relay. So 2002C088-1E01::1. That is your gateway. It's your gateway to the rest of the internet. So all your IPv6 traffic defaults and goes there, and then routed going to the different IPv6 networks. Okay? It uses Anycast, by the way, so you can have a look at that. It's RFC 3068. Questions? So these are the blocks that are used in 6 to 4, and then the Anycast addresses, both in IPv6 and IPv4. For IPv4, it's this one, 192.88.99/24. For IP, no, I don't think there's IPv6 there because it uses IPv4 unicast when it goes through the tunnel. Okay, any questions? This is the entire configuration for your 6 to 4, just in case you want to replicate that on your own. You will have a copy of the materials later on, so you don't need to take a screenshot or whatever. Now, the other one is 6RD, or 6 Rapid Deploy. 6RD is a faster deployment compared to 6 to 4. It's actually based on the 6 to 4 implementation. It's derived from 6 to 4, and it stands for Rapid Deployment. So if you look at RFC 5569, it publishes the description of how it was first used. 6RD is a typical technique used in those times for mostly easy, fast implementation, let's say in universities or research institutions. That's basically how it started. This technique is used to communicate different IPv6 islands to the core. It's very similar to the tunneling techniques we've discussed with 624, with two major differences. 6RD does not require address to have the same prefix. You don't use 2002/16. You can use your own prefix. The prefix can be from your own service provider's address block. This function allows the 6RD operational domain to be within your service provider network. So that's a good thing. Here we get a very interesting point from the perspective of customer sites and the general IPv6 internet connected to the 6RD enabled service provider network. And IPv6 services provided is equivalent or very similar to a native IPv6 deployment. So that's one of the positive comments with 6RD when it first came out and when it was used for quite a while. Now, in this example here, you can see, as I've said, we're not reliant on the 2002/16 block. Here we are using our own service provider block. So for example, we have 200 and DB8 slash 32 for our network. If you want to assign /48 for these part of our network, we will basically just use the last two octets of our IPv4 address. So 4002 here is actually 64.2 in IPv4. Same with 6 to 4, you can also set up 6RD relays that makes it easier for you or for your network to connect to the rest of the IPv6 internet. Okay, so have a look at this think there are newer implementations. You have actually have a lot of choices when it comes to internet, sorry, transition technologies, and this is just one of the popular ones that have come up. All right, another one is tunnel broker. Now, I've had some people um, come to me, and I've actually done this before as well. Use tunnel brokers just for trying it out. So maybe your customers or your enterprise network, you're not exactly ready to use IPv6 yet. Maybe you're because of your infrastructure, the support, the compatibility, but you want to have, like, say, a test network that has connectivity to IPv6. And one easy way to do that is to use tunnel brokers. With tunnel brokers, it's like setting up manual tunnels. But you're setting up a tunnel going directly to the tunnel broker. And with that, you also have the access to the rest of the IPv6 network, similar to how relays work. So how do you go about this? There are some available tunnel brokers out there, some provided for free for, let's say, personal or enterprise use. Some would be for, I think, subscription based or something like that. So with tunnel brokers, notice that when you say sign up for them, you must have a network or router that is accessible via the internet. It should have a public IPv4 address. And then it will give you an IPv6 block. When you do this, please notice what block you are getting. Okay? Um, and that's because, like, it's similar to when we did our manual tunnels earlier on. So when you do that, you'll have to configure your machines to use that IPv6 address and then connect to the IPv4 address of the tunnel broker's router or interface. So that's pretty much how it works. With tunnel brokers, it makes it easy for you to try out IPv6. Okay, and the main difference between a tunnel broker and 624 mechanisms is that they serve a different segment of the internet community. With tunnel broker, it fits mostly small, isolated IPv6 sites or IPv6 hosts on the IPv4 internet that want to easily connect to an existing IPv6 network. With 624 approach, it's designed mostly to allow IPv6 sites to easily connect together, so one side to another side, without having to wait for your upstreams, your IPv4 ISPs, to deliver native IPv6 connectivity. So if you're setting up, say, extranets or virtual private networks, you can use this. So again, they serve a different purpose or a different segment of the IPv6 community. I think there's another question there from Kizer. If our ISP is going to use 192/16, that's private address, can we use same in our LAN on the translation, or the translation will not work between the same network in the router? Ah, you're talking about translation techniques. Now, it depends on what device you are using. There are known issues with translation when you have the same, say, set of private addresses, or basically set of IPv4 addresses used for both sides of the link. So you'll have to test that yourselves. Generally, it should work, but there are isolated cases or reports that it doesn't for particular types of devices. It cannot do a proper translation with when you're using same IP address range or blocks. Okay, so I hope that answers your question. Any others from the class? So I think those are the stuff that we want to cover essentially. We'll just be wrapping up by looking at some of the ways, perhaps, or strategies that you can think of after attending this session. So these are some of the things that people do. Okay, the first one is actually not doing anything. So they're just waiting out there. They have IPv4. IPv4 is working, and it's not affecting them because yes, their business is working in IPv4, right? So we just wait for IPv4 to run out. Please, if you're in this stage, please don't do this, because as I've said, there is it is good that you start deploying IPv6, because your network will not grow. It will become stagnant. Okay, it will not help your business grow as well. So start deploying, start understanding about the IPv6 transitions, start auditing your network devices for compatibility and support. Um, and if you're still not ready to do IPv4 and IPv6 dual stack implementation, what other people would also do is to extend the life of IPv4 network, and that is using translations. So they use NATs. Okay, so with NAT, you obviously have IPv4 networks inside mapped to a single or just a couple of public IPv4 addresses, right? You're using the private addresses, or actually 1 and 1/8 addresses in your infrastructure. Or another thing that they would do is to have more public IPv4 addresses. They would acquire it. They would buy it from other organizations. They would request for more. If you still have provision to request for more IPv4 addresses from the RAR, then you can also do that. But essentially, to get more IPv4 addresses, that will allow your network to still grow. But at some point in time, you will still hit the mark where you cannot extend that any longer, and you will have to implement IPv6. And that's where dual stack networks, maybe a bit of tunneling, a bit of 6RD, a bit of using different large scale nets would come in. So I've said there are many different technologies, and one technology may be best suited for you and not for others. So what I would suggest for you to do is, again, try to understand your network situation, and then look for similar implementation that has been done by people in the community. So if you look at the APNIC website, we have a page there that looks at IPv6 transition deployments done by different types of organization, big ISPs, service providers, enterprise networks, and how they go about it, what kind of transition mechanisms they've used. So maybe look at their implementation process and learn from them. If you need to, this is an internet community, you can like come to us and we can get you in touch with different experts as well. And that will somehow help you get started with your IPv6 deployment. All right. So that's basically, I think, what I want to impart for this particular session. If you have time after this, go have a look at these different transition technologies. Okay, we have their dual stack, IP and IP, that includes GRE 624 that we've discussed, 6RD we've already discussed. Some others that we won't have time to discuss in this short time is AFTs, address family translations, NATs, NAPT, NATPTs, and CGNs, carrier grade NAT. So have a look at these different transition mechanisms and see for yourself how you can use them or a combination of them during your transition process. Okay, so that's pretty much it, everyone. Thank you very much for joining me in this session. If you have any further questions, now is the time to write them down on the chat. Now, if there are no questions, well, I'm going to write down a link to a survey. So this survey, if you can, please fill it in. It should just be a very short one. It takes a couple of minutes to finish. So please do fill it in for me. And then after that, you can also download a copy of the materials. And that's found on our FTP site. I'm also going to write down the link to that. So this is the link to our FTP page. So you can download a PDF copy of the materials. Again, I'm suggesting that you visit the APNIC website. We have there some good resources on IPv6 transition. All right. Any other questions? Oh, by the way, if you don't have your IPv6 resources yet, of course, that's the first thing that you need to do. come and check with us, with our help desk team, to obtain or get your IPv6 addresses. So if there are no more questions from everyone, thank you very much for your time and for your attention. You can still email us at training@apnic.net for any further questions coming from you. Anyway, thank you very much, and I hope to see you again in another e-learning session. Thanks. Bye-bye.